Last but definitely not least, I'd like to welcome back Jeremy Mill again. He was a speaker in one of our previous BSides, and he's going to be speaking on effective adversary emulation. Thank you, Jeremy.
Awesome. Yeah, thank you. Yeah, so I guess we're bookending people who started speaking at BSides 2019, right? So, bringing it back from where we started. Yeah, so I'm doing an effective adversary emulation, right? This is specifically really aimed at like small, medium-sized businesses. This is not aimed at like, I'm a Fortune 500 and I have a red team with 20 members, right? This is definitely much more focused on teams that are running much more lean. Who am I, right? I'm Jeremy. Where is that documented mill? You can find me on Mastodon, on GitHub. My background, I started in military SIGINT. I was a sysadmin, then I was a full stack software developer, then I was in AppSec, then I was in IoT pen testing, and then I ran a security team at Puppet, ran a CNA, and what I'm doing now is I manage the security team at Varo Bank, right? So, what it is that makes me tick, right? I enjoy making bad guys frustrated, right? That's kind of my goal. It's what I really like. It's one of the reasons I like working in fintech, because there's a lot of real bad guys who are actively trying to steal people's money all the time. Why this talk, right? Most of the people in this room don't test. Like, you might say that you do, you might tell your regulators that you do if you have them. You might say in your SOC 2, like, yeah, we did a pen test, but that's not the same thing as actually rigorously testing. When we do test, we suck at it. Like, we're genuinely not good, right? Like, when we dig into why tests succeed or fail and root cause analysis and rigorous testing, we're bad. And we suck at it because a lot of these testing resources that exist for people in those small and medium-sized teams, the vast majority of organizations, right, they're way too complicated, right? One of the reasons they're too complicated is because they're focused on emulating attackers exactly, right? They're talking like, oh, we're going to emulate Fin7 down to exactly what C2 they're using, down to exactly how they delivered it, exactly how they moved laterally. Well, like, that doesn't even make sense, because when they attack your org, they're going to do something different. Right? So exact adversary emulation, especially the stuff, being released by MITRE, it doesn't make sense, right? Or we treat our test as pass-fail, particularly looking at everybody in this room who did their yearly pen test, didn't get domain admin owned, and said, yay, we've succeeded, and moved on with their lives, right? That's not good enough, right? We have to do better. The last thing that we do really often is we test tools individually, right? We might just test our EDR, and we're like, cool, we caught something, right? Our EDR is working successfully, right? But that's not how we deploy things, right? It's not even the model that we think of, because we talk about things like defense in depth. Like, why test it all, right? So we talked about defense in depth. We've got a network security tool, right? We've got a bunch of Palo Altos running. We've got a Cloudflare WAF, AWS WAF, Fastly, something, right? Controlling ingress. We've got zero trust, right, deployed around our network. We've got a fancy EDR or an XDR. We've got a SIM, and we're aggregating all of our logs from all of our systems. We've got a WIFO tool. I don't know what that is, but every single one of you wouldn't be surprised if somebody outside was selling it, right? Like, you just wouldn't be, right? We need to know that they work together and that they actually work, right? Because we're expecting them to defend in depth. But if we don't test them that way, we have absolutely no idea that that's the case, right? And we need to do it regularly, because the TTPs that attackers were using a month ago are not the attacks that they're using today, right? We just learned a ton of stuff at MGM, right? We have a whole bunch of new TTPs that we're concerned about. A year ago, right, would anybody here have been concerned about like a deep faked audio call to their help desk? Like, maybe, right? But like, you might be the only one in the room, right? And that's awesome. But like, the vast majority of us might not have even been on our radar as something that was achievable for the attackers that we were facing. But like, really why? Is because like, every time I've done this, and I've done this in several different orgs, I've done this in several different contexts, I have been shocked Not like a little shocked, like, uh-oh, we have to make immediate changes right now shocked, right? By basic changes that reflect the attacks that we're facing today. And it's better to find out right now, right? Like the best time to test was like yesterday, the next best time is now. And one of the reasons is that if we don't, and we don't find out where we're not doing well, we might never know because all of our stuff's encrypted, right? It's been ransomed, right? We're gonna find out that our backups fail because we also didn't test our backups, right? And then we're really screwed. So I've convinced you, right? Well, with my 7-step solution, you too can test, right? We're gonna scope. We're gonna do some research through our TTPs. We're gonna design an effective test. We're gonna weigh the elements of that test so that this is something that actually has some rigor and some way for us to have a feedback loop. We're gonna talk about executing the test, right? And scoring it against those weights. We're gonna take the results from that, turn it into some kind of plan. We're gonna talk about actually like doing something with it because just putting it on the backlog isn't gonna save you. So, scope. This is an objectively incredibly simplified version of what it is that you might have, right? So you're a company that produces some software that you run as a SaaS, right? So you've got like the user internet, you've got email that comes in, maybe those two should actually be on top of each other, right? Sort of doesn't matter for the purposes of this. You've got a bunch of endpoints, right? Those endpoints are running everything from software developers to your accountants, right? To the administrative assistants who help schedule your CEO, right? They're talking to some kind of user auth system, Okta, Azure AD or Entra or whatever they changed their name to avoid lawsuits, right? Those developers talk to a CI/CD system or to the cloud provider, right? Because you're hosting some stuff. And then you've got cloud egress, right? From your CI or from Kubernetes, or your ingress, right? Coming in through that WAF that we talked about for those SaaS solutions. If we try to test all of it, if we try to build one test that tests all of the security controls that are in the scope of that, right? You'll be testing for the next 2 months. You'll probably be testing so long that the results don't matter. And even if they do, your backlog's going to explode and it's useless, right? It's just too big. Doesn't make sense, right? It's too large of a timeline, especially if you don't have that really large security team. So what we might want to do is break it up into, hey, we're going to test our cloud infrastructure, right? We're going to emulate something like a Log4j style attack, where one of our servers or container that's running in Kubernetes is the one that gets popped, right? Can we detect that exploit coming in? Can we detect C2 comms going out, right? Entirely in the scope and context of our cloud infrastructure. Or we might want to do the opposite, right? We might want to test that malvertising type situation, right? Starting just from like a user clicks on an exe, right? And where do we go from there? And what do we detect, right? Scoping is really, really important to this, right? Too big is a huge problem. Too small, and we lose too many of the tools that we're talking about from our security program to effectively evaluate our defense in depth. It's organization specific, right? And you'll see me hit on this a few times, right? But like everything you do, you should know where your crown jewels are. What is it that your business has that's important, right? Is it a giant database of PII, right? Is it your customers' money? Is it your customers' API tokens because it would let a compromise of your system get into theirs? What are your crown jewels, right? Spend your time on those things because those are vastly more important than anything else that you can do. The next step is to evaluate your TTPs, right? And you're gonna have to decide what kind of hacker are you. You know what I mean? Maybe you're the typical black hat, black hoodie style hacker. Maybe you're this guy, right? I can only assume this is the guy who hacked MGM, right? Just standing way too close to screens. Or maybe you're working, I can only assume for the NSA, because you got a much nicer desk and a lot more funding than everyone else, right? The choice of the TTPs that you pick in this step are the result of your scope, right? You're not gonna be researching, Istio control plane bypasses if you're testing your user email exploits, right? You're gonna spend your time researching how it is that the various attackers that attack organizations like yours work for the scope of your test, right? Again, coming back to those crown jewels, right? Aiming it around that critical information and those critical people and processes where they live, right? And for this step, you're keeping it high level, right? You're just doing general research. For me, step 2 never really finishes, right? I kind of just watch this all the time. I have a notebook that's literally just filled with like, ooh, that's a cool GitHub repo, or a particular threat intel report that told me like, hey, this is new, right? This is interesting, right? Or I've seen this, you know, over 5 reports now of some DFIR people talking about it. Maybe that's something I want to pay attention to and revisit when I do this. Because I'm going to take all those, right? I have all those TTPs and I'm going to bring them into a plan, right? And I'm going to use something like MITRE ATT&CK to help keep myself organized, right? Around like, how do they do recon, right? How are they doing initial execution, right? Is it a Word doc with a link inside of it, or is it a macro? Is it an encrypted zip file, right? However it is, right? I'm going to use that to help build this into a cohesive plan. But you have to be able to execute it, right? We talked about one of the reasons people don't test is because stuff gets too complicated, right? So we're going to only use stuff that we can find, right? And that we can use. So we're going to use a lot of open source tools, right? For things like EDR evasion, right? For some of the basics that we're going to try and do, right? And this step includes actually getting those things and building it, right? That's a really important part of this, right? If you build this wonderful plan, but you can't pull it off, right? Or you spend all of your time on Stack Overflow because it didn't work the way that you thought it was going to, then this test also didn't work, right? So make sure that that's a key part of this, right? So example of a high level design, right? We got a developer on Windows, he's got local admin privileges, and he downloads a backdoor npm package, something that is way not out of the ordinary, right? If you're paying attention at all. That package is going to download a stager from someplace, maybe from GitHub, maybe from Pastebin, right? Somewhere. It's going to persist with a scheduled task, right? That stager is going to download some sliver shell code and execute it, right? We're going to escalate with a bring your own vulnerable driver attack. We're going to use cursed Chrome to steal an Okta cookie out of a session. And then we're going to use that stolen cookie from an alternate location to log into the cloud provider, right? And that's where our scope stops, right? So we've got a tightly bound scope, right? A limited number of tools that we need to bring into our engagement, right? This is something that we can actually pull off, right? With the right number of engineer hours, right? Same thing here. I like to try and at least draw some pictures through this. One of the reasons is that I also have a boss that I need to go and tell them what I'm about to do, right? Because one of the people I test through this is, if you have an MSSP, right? Hey, they should probably alert on this also. They're supposed to be watching. If they don't, you get to have a fun and really difficult conversation, right? But one that's important to have now under controlled circumstances. And you're also probably going to need to tell someone from the C-suite that you're doing it, because they really don't like surprises about critical level alerts, especially if those alerts get misrouted, right? Same thing, right? Build yourself a nice flow diagram, right? As part of this design, so you know exactly what you're doing, right? And you're covering all of the steps through it. This is where the rigor starts to come in, as in step 4, right? We've got an excellent design. That's cool, we've got a plan. But not everything is as important as the other ones, right? The event that we see for a new scheduled task, right? New scheduled tasks happen all the time. That's not a critical alert, right? Most of the time. It might be something that we want the SOC to take a look at, right? If they're there, but if they're really busy, they're not gonna, right? That's way less important than Sliver actually running in the C2 comms and it performing actions on the computer, right? Way, way more important. We need to treat them that way, right? So we're going to break down every one of those steps that we have into a tuple of what happened in the tool that should have detected it. And we're going to assign a weight to that. Why? Because that's what we're going to use to prioritize based on the results of how well we did, right? In its really basic form, right? This is just an overall weight. This is, did the EDR detect the new executable it's never seen running, right? That's it. EDR, new executable run. In a more advanced form, as you start to get better at this, that can break out a little bit more. Now it's, did the EDR see it? Okay, well, it's a stager, it's malicious code, right? Heck, it's malicious code we wrote for the purpose of this test. Did the EDR see it and alert on it, right? Did we get an actual alert that got raised to somebody who has to actually go and click through and find it? And did our automation do its job? Did we automatically stop it? Did we kill it? Right? Did we isolate this box because, hey, this was actually something really malicious, right? We can get more advanced with this as we go. So here's an example of that. Again, just looking at that basic way of doing it, right? You know, the dev downloading the NPM package, we want to be able to see that firewall. It's not super important. We're going to give it a 2, right? The attacker uses the Okta cookie from Romania, right? Boy, if all of a sudden my user travels from San Francisco to Romania in the span of 5 minutes and starts logging in and performing actions, I really, really want to know, and my tools better detect it, right? That's like, emergency levels of action that my team should be taking right now. That's a 10, right? What that weight scale is subjective, right? I use 0 to 10. I know other teams after I've left have adjusted this to 0 to 5. They find that better. It sort of doesn't matter, right? As long as you're consistent. Cool. So we got a test plan, right? We have all our tools, right? It's time to do it, right? And this is the super fun part, especially if you work on the blue or sort of purpley side of the house, right? You get to actually like be a hacker for a little while, and that's really fun. As we do it, right, we stand up our C2 server, we go ahead and we send our email with a link to an executable, right? Or, you know, we have that simulated user run npm install with the malicious package. We're going to mark down its weight with how effective it is, right? Blocked and alerted, yay, you get all the marks for that one, right? Logged only, it didn't block, you know, we really wanted to block that one, right? We're only going to give it a 1 out of 6. Here's a really important difference between this and a pen test, right? If during somewhere of this exploit chain, right, of our test, we succeed, which is to say that our EDR blocks it, right? It just gonna keep coming back to that when it's an easy one, right? Doesn't mean we're done. That isn't it. We didn't win, right? That's only one of the things that we're testing today, right? What we need to do is mark it as a success, right? Which is to say we give it full marks. We're going to allow list it in the EDR, pretending that it didn't, and we're going to continue with the test. Because we weren't just trying to test the email gateway in the EDR, we were also trying to test the SIM and Okta, and can we detect C2 communications going outwards in our firewall, right? If we stop the test there, we don't get to test any of that other stuff, right? We also want to only allow minor deviations, right? It's really tempting to be like, no, but what if we did it this way instead, right? Don't do that, because one of the things we need to be able to do is repeat the test. That's the reason why there's rigor in it, so that if we make changes, we can evaluate whether or not we were successful, right? And any changes that we make in the middle of testing, guess what? We're not going to write it down, no matter how much we say we're going to or how careful we are to try, right? It's also not what we got approval from our C-suite to go and do. Right? So only allow minor deviations, right? Which is to say, like, all right, we did some encoding. We're going to go from ROT13 to XOR. Go for it. We're going to change our entire C2 framework and change the way that we're deploying it. Probably not, right? Not for this one. Then we have to plan, right? Because unfortunately, the fun part's over, right? The part that at least I find really entertaining. But it's the part that like gets us paid, which is great. I'm a huge fan of that part of this step. What we're going to do, right, is we're going to take that score, right, all the scores that we had, and we're going to compare them to the weights, and we're going to calculate weight score deltas, right, and we're going to perform some root cause analysis and determine why certain steps failed, right? What do we need to do to make it not fail, right? And we're going to use those deltas in order to prioritize it, because if it was a 10.10 weight task, and it only scored a 1, we have a delta of 9, and that is our priority, right? Prioritization is done, Our backlog grooming is in a really good place, right? And we're gonna go ahead and turn that into tickets. So we track it, so it doesn't stay inside of a single Excel file on a shared drive somewhere, right? We're gonna actually put it where it needs to go. Maybe we'll even have an epic if we're feeling fancy so we can track whether or not it got done, right? This is that same one I showed you before, but with some hypothetical calculated deltas, right? I tend to use a low, medium, high critical scale, right? Because that's how my Jira board's set up, right? Anything that's highlighted in green there, right? That's going to be informational. Maybe there's something there, right? Maybe we can tighten that up. Maybe because it's super low hanging fruit, it's real quick, right? Cool. We can pull that in at the end of a sprint with some extra time that we have, right? But what I need to be doing is looking at Okta and why it didn't log, or why that log didn't end its way up into the SIM, why that didn't fire, and why my MSSP never called me about it, right? We got all of those done by just being rigorous with our test definitions. And then the last thing is, I know what all of your backlogs look like. I know because we're all in the same boat, right? We all know that we don't have as many people as we want, nor do we have as much time as we want, and everything's moving super fast, right? But we have to use that prioritization and we have to fix it, right? And then lastly, right, just making a change isn't the same thing as fixing something. If you just make a change and you don't rerun the test, which goes back to why we only allow minor deviations, we have absolutely no idea if we fixed it. We just kind of made a change and hoped, right? That needs to be inside of our definition of done for these tickets. One of the things that I find really useful, just on my soapbox, while I'm talking about number 7 and number 6, around the planning stages, is measuring how much of your team's time is focused on proactive work versus reactive work, and having every ticket have that on there. Because if more than half your time is spent on reactive stuff, you have a great measurement for you to bring to the rest of your management and go, we're falling behind. We won't ever catch up because we're spending more time on this, something needs to change, versus this is proactive work. This isn't in result to a failure, right? You're not doing an active investigation and incident response. You're changing things before something terrible happens, and that is always better for your team to be working on. And then last, do it again, right? Pick a different scope, right? Move somewhere in the middle. Maybe we tested purple last time when we have a hypothetical green box between endpoints to our CI system and a little bit in K8s, right? Can we attack Artifactory and get a backdoor package in there, right? If there's an attacker who has decided, or if there's a developer who's decided to break bad or something like that, right? Continually redo this process to feed back in and make your security program a better and stronger place. Let's say I've convinced you and you're like, yeah, I'm gonna do this, right? First of all, awesome, right? I'm stoked, right? You're gonna do your first one, start small. And I mean, take what you think is a small test and then make it smaller, and then probably reduce your scope a little bit, right? Because like I said, every single time I've done this, I've been shocked. You're probably gonna have a little bit more work cut out for you than you think you're going to have. And there's no penalty to starting too small the first time. There is a penalty to starting too big. So if you're going to fail in one direction, absolutely fail on the side that lets you succeed and have actions coming off of it. Don't get too fancy, right? There's a lot of fancy stuff. There's a lot of fancy stuff that attackers do in the real world, and that's super cool, right? Process hollowing, module stomping, dynamic call stacks, all that stuff is awesome. I love nerding out about it. I love writing it. I love doing so much with it, but chances are you don't need it, because the basics work really well, right? By the basics, I mean Netcat, reverse SSH, Python reverse shells when you're on a Mac OS system, right? Base sliver executables that are compiled by just running generate and emailing it to a user. The basics work way better than you think they do, and that's why we're doing this, right? So a good first test, right, is even scoped down from what we covered during the design phase I introduced with, right? An email with a link to an AXE that a user downloads, execute, it persists, and it steals some files. That's it. That can all happen with nothing but one sliver C2 server and an email. Right? All of those steps can happen inside of there. And I bet you that will cover 3 or 4 of your tools and give you actionable items to use as you do your next, annual quarterly planning. For me, right, these are taken from my most recent test because I find a lot of people talk about stuff like this and they don't actually talk about how hard it is and how much time it takes. And that's a disservice because otherwise you're kind of left in the dark and guessing for yourself, and that's not fair, right? You should learn from experience. I use mostly open source tools. Collection of those tools took roughly 3 to 6 engineering hours, right? So that's one day, but in truth, that's split over a long time. Like I said, I got that notebook. I love to lurk in places like the Bloodhound Gang Red Team channel, right? That's a Slack, sorry, that word is missing from there, but their Slack channel is open. Their Red Team channel is great. The Covenant C2 folks in there, the Bishop Fox Sliver folks are in there. There's a bunch of just people doing the job, and it's worth looking to them because they're also learning from the bad guys, like some other speakers have talked about. I wrote some tools because that tickles the fun part of my brain and I enjoy it, right? So I wrote a stager in Rust that at least for Windows Defender and EDR, it completely avoids it. It was blocked by some of the other tools that we have, which is great, but all of these things are sort of hit or miss. And I used a sample backdoor Python library, right? So this is just something that has, that downloads that stager and then is used to call it a sliver. Infra setup, the first time it took roughly 6 hours. I had no idea what I was doing, right? Now I could do it in an hour, probably less. I've actually terraformed most of it, so I can literally just click go, and I've got all my test infrastructure up and ready to go for some of the common tools that I use. Testing itself, if I ran this test myself, I'd probably spend about 5 hours making sure that I do it thoroughly, right? And allowing myself time to make some minor deviations. With 2 engineers, that doesn't get better, it gets worse, as I'm sure all of you know. But, right, I've been doing this a hot minute. I've got both senior and junior level engineers in my team, right? That extra 3 hours or even 16 hours are worth it because I've spread that knowledge to them. I've made them better at what they do. Oh, I'm gonna keep just losing my screen. And then I've got some resources here, right, around some stuff, right? So Sliver and Covenant are places tools that I really like to use. The real recommendation for all of these is whatever bad guys are using, right? Going back to our TTP recommendations. AppleScript phishing is super easy because you can literally just pop up a window and users love to type their passwords into stuff that pops up. Cursed Chrome and Cursed Edge are awesome because everything is a SaaS tool nowadays. So you might as well just steal some cookies and become them. And then persistence, again, whatever they're doing these days, because I'm not keeping up with the new fancy stuff. I know new macOS persistence was dropped on Twitter or X or whatever it is now yesterday. Right, so my next test, maybe I give that a try, and I'll find out whether or not my EDR is keeping up. So anyway, that's my team's methodology to adversary emulation. Right, it doesn't try and get too fancy around a single threat actor. Right, it tries to be much more rigorous around our definitions of how important things are, and we use that on a regular loop to improve our security process and find out stuff now before bad guys do. Any questions? Yeah.
What software do you use for your design stage?
Excel. Because I'm a manager and that's where 90% of my time lives now. I wish there was a better answer to that question. If somebody has a better one, I'm all ears. Hit me up. We'll talk about it. Oh, the pictures, I use draw.io because it's free and hooks up to Google Workspace with a good privacy policy. And it hooks up into Atlassian. So if you're in that world, it's easy. Yeah.
So you've developed these test cases. You've got tests that you've executed.
Yep.
Do you have a method for rolling that back into your pipelines through automation? Do you have tools that you use to integrate that kind of stuff?
We have a lot of automation tools, right? So places where we try to, my team personally, we try to get ops as many things as we can, right? So, but largely what we're talking about, the feedback from this is changes to existing tools. So you know, that might take the form of, you know, a pull request or a merge request that's gonna end up inside and changing the configs of some of those toolings. Or it's just gonna be a JIRA ticket and an engineer physically picking it up and going and making the changes. In its most extreme form, this is being able to point to, this tool actually really sucks. We can't continue to pay this tool, right? And this is good excuse to, you know, go and purchase something else.
And do you continuously manually test these test cases?
This
Or
test,
do you automate
yeah,
the suite?
yeah, this test in particular, right? This methodology is very manual, right? And something that is, because this is what I would consider like an integration test. I think it's a really interesting idea to automate some of this. And I think there's some vendors that promise to do that, right? But I don't have a good way right now to, you know, I can't think of a way right now that would be worth the time to automate doing this in any kind of basis, routine basis, you know, weekly or monthly.
What are some tests you would run on a network that's supposedly blocking out all outbound requests?
It's a great question. The question was, what would I do if it was a network that's supposedly blocking all outbound connections, right? I would probably test that differently, right? If my premise is a host, right, on this network actually blocking all outbound, right? I would probably design the test differently by looking through every protocol and every situation that I can, right? So what I mean by that is like, is DNS actually being blocked, right? Is DNS like upstream resolution being blocked, right? Are there different resolvers that work differently? Is ICMP actually being blocked, right? I would design it differently than this sort of enterprise, you know, tool stack test. But it's a really interesting question. I'd love to go and design it and actually do it. I've never had that actual premise. It'd be fun. Yeah. Awesome. Well, if you have any more questions for me, I'm around. I'm gonna step over to the after party. Thank y'all. I appreciate it.